Hello everyone and welcome back to the next session on assignment problems. So what are we doing? We are solving an assignment problem. What is an assignment problem? When a certain number of jobs is supposed to be assigned to a certain number of people, we use assignment problems. It comes under a section called OR in statistics called operational research. It is a management technique and that is why it is being put into your syllabus under the section operations management. So what are we doing? We are optimizing our work. Up till now we could do the work and we are doing it, but now we are going to check if the work can be done in a slightly better way by using resources efficiently, by minimizing time and hence minimizing cost. What are the steps to solve an assignment problem? Well, the first thing is you do a preliminary check. Check your objective. It is minimization, fantastic. If it is maximization, sorry, change it to minimization. Select the most maximum, subtract it from every other element. Check number 2 or preliminary check number 2, is the problem balanced? That is it an n cross n matrix? That is, are the number of rows and the number of columns equal? If yes, fantastic. If not, make them equal by adding a dummy row or a dummy column. And the last preliminary check, which is check number 3, is there a prohibition? Due to any technical or physical or any difficulties, legal difficulties, is there a certain assignment that can't be made? That this particular person cannot do this job or this particular vehicle cannot transport to this particular location. Anything that is a prohibition. If there is a prohibition, put that prohibition into the table and act on that prohibition. Some people put a very big number, some people put an M there. I just put a dash or an infinity sign and act like that cell does not exist. After doing that, step 1 row reduction, step 2 column reduction, step 3 assignment. Row reduction is select the least from every row and subtract it from every element. Column reduction is if after row reduction there are still columns that don't have a 0, select a least from that column and subtract it from every other element. And the third, once you are done with row and column reduction, you start assigning. How do you assign? You do a row examination, come to that row that has exactly 1 0, mark it as an assignment and cancel every other 0 in that column. Once you are done doing row wise, if there are still zeros left, start doing it column wise. Keep doing this till all the zeros are either marked or cancelled. After doing this, the number of assignments that you have should be equal to your number of rows and your number of columns. So if you have 4 rows, 4 columns, you need to have 4 assignments. If you have 5 rows, 5 columns, you need to have 5 assignments. If you have 8 rows, 8 columns, you need to have 8 assignments. If you don't have those many assignments, you have to move on to the next job. And that job is changing the reduced matrix so that you get those number of assignments. And how do you do that? Well, changing of the matrix is done by drawing lines. Why are we drawing lines? To cover all the zeros. How many lines? Minimum number of lines. How do I know what is the minimum number of lines? How many assignments did you get? Well, I was supposed to get 5, but I only got 4. Fine then. Cover all the zeros in 4 lines. How? Mark a row that does not have an assignment. In the marked row, mark a column that has a 0. In the marked column, mark a row that has an assignment. After doing this, keep repeating steps 2 and 3 over and over again till you come to a point where no more marking is possible. Draw lines through unmarked rows and marked columns. So look at what the unmarked rows are, draw lines through them. Look at what the marked columns are, draw lines through them. And then check 2 things. Number 1, are all the zeros covered or not? And because that was the entire idea, to keep the zeros safe and change the matrix. And number 2, and that is, how many lines have you drawn? If you had 4 assignments, then you should have only 4 lines. If you had 3 assignments, then you should have only 3 lines. Minimum number of lines. After doing that, you change the matrix by this small rule. You will see 3 types of elements: uncovered, single line covered, and junction, which is double line covered. Select the least from the uncovered and subtract it from the uncovered. Add those elements to the junction and keep the single covered alone, untouched. Do not do anything to them. After doing that, you go back to row reduction, column reduction if required. Most of 99.99% of the times it is not required. Just in case it is required, row reduction, column reduction, assignment. If you get an assignment, thank your stars and write down your final answer. If not, you will again redesign the matrix by drawing lines and again make an assignment. You will keep doing this till you have or your number of assignments is equal to the number of rows and the number of columns. If not, you will keep doing this in circles. And that is how you solve an assignment problem. Let's quickly come to the question that we are going to do. I think last time we stopped at question number 14 if I am correct. And I think that was the only question that I did in the entire session. Yes, was this the question? Yes, I think we did question number 14, correct? So now let's move on to question number 15. This is question number 15. What is given to you? Solve the minimization problem. Okay. So what is given to you? A, B, C, D, E, right up till F, and 1, 2, 3, 4, right up till 6. So let me not waste time. Let me pause the video and write down my question and then we will continue. So I have the question ready. Let's start solving. So you have to again minimize this problem. Fine. Which means preliminary check. Question number 1. What is the objective? To minimize. Well, if the objective is to minimize, nothing like it, because my assignment problem can only minimize. Fine. Question number 2. Is the problem balanced? Yes, it has 1, 2, 3, 4, 5, 6 columns and 1, 2, 3, 4, 5, 6 rows. So 6 rows, 6 columns. Is there a prohibition? Well, it's not really mentioned in my question right now. So I'm going to say no. Let's begin then. Step 1 is going to be row reduction. What do? You pick up the least from every row and subtract it from every other element of that row. So A, B, C, D, E, F, 1, 2, 3, 4, 5, 6. First row, the least is 5, 21 minus 5 is 16, 52 minus 5 is 47, 19 minus 5 is 14, 32 minus 5 is going to be 27 if I am right, 5 minus 5 is 0, 31 minus 5 will be 26. Let's come to the next row, the least is 2, 2 minus 2 is 0, 9 minus 2 is 7, 29 minus 2 is 27, 45 minus 2 is 43, 61 minus 2 is 59, 30 minus 2 is 28. Let's go to the next. The least here also is 2. 2 minus 2 is 0, 14 minus 2 is 12, 35 minus 2 is 33, 26 minus 2 is 24, 7 minus 2 is 5, 7 minus 2 is 5. Let's go to the next row, row number 4. The least here I think is 7. So 15 minus 7 is 8, 20 minus 7 is 13, 18 minus 7 is 11, 22 minus 7 is 15, 7 minus 7 is 0, 13 minus 7 is 6 if I am correct. The least in the next row is 1. So 4 minus 1 is 3, 15 minus 1 is 14, 14 minus 1 is 13, 1 minus 1 is 0, 5 minus 1 is 4, 8 minus 1 is 7. And if you look at the last row, there is already a 0 here. So no reduction required. Let's write it as and how the values are. So step 1 row reduction is done. Step 2 column reduction if required. Let's check if all the columns have zeros. Column number 1 has zeros. Column number 2 does not have a zero. Fine then. If at least one column doesn't have a zero, I have to do a column reduction. I don't really have a choice. So I'm going to say step 2 column reduction. So A, B, C, D, E, F, 1, 2, 3, 4, 5, 6. First column already has zeros. If the first column already has zeros, then no need of reduction. We can write it down as and how it is. Am I right? So let's write the first column down as and how it is. 1600 8352. The second column does not have a zero and the least is 7. Well, then subtract throughout by 7. 47 minus 7 is 40. 7 minus 7 is 0. 12 minus 7 is 5. 13 minus 7 is going to be 6 if I'm right. 14 minus 7 is 7. And 10 minus 7 is going to be 3. Let's go to C. Does not have a 0. Okay. What is the least then? Oh, the least is 10. Well, then subtract throughout by 10. 14 minus 10 is 4. 27 minus 10 is 17. 33 minus 10 is 23. 11 minus 10 is 1. 13 minus 10 is 3. And 10 minus 10 is 0. Let's go to the next D. Already has a 0. Well, then no reduction required. 27, 43, 24, 15, 0 and 30. Already has a 0. Well, then no reduction required. 0, 59, 5, 0, 4, 21. No reduction required. 26, 28, 5, 6, 7 and 0. Step 1 row reduction, step 2 column reduction. Done. We now move on to step 3 and that is assignment. Sir, can we assign in this? Technically you can, but I don't want you to. I want you to make a new table. So I'm going to make a new table here and that is going to be, so let me write it here. Step 3 assignment. So that this is at the same level as the ABCD. So I have 1, 2, 3, 4, 5, 6, A, B, C, D, E, F. Correct? Let's write down the matrix as and how it is. So I'm not going to show it to you. I'm directly going to copy 16008352, 16008352, 405673, 405673, 4172330, 4172330, 2743 for 24 15 0 30 0 59 5 0 4 21 26 28 5 6 7 0. Step 1 row reduction is done. Step 2 column reduction is done. Step 3 assignment. Let me zoom in a little so that the assignment bit is clear to you. So let's start the assignment. How are we going to begin the assignment? Start row wise. Row number 1. Exactly 1 0. Perfect. Then mark it as an assignment. In that column, if there is a 0, cancel it out. Go to the second row if you want, and if you think there's going to be a confusion, draw a line here and then draw a line here. Let's go to the second row. 0 0, no. 2 zeros, can't do anything. 1 0, perfect. Mark it as an assignment. Cancel every other 0 in that column. 1 0 already cancelled. 1 0, perfect. Mark it as an assignment. Cancel every 0 in that column. No other 0. 2 zeros, I cannot do anything. Let me start doing this column wise then. Done. 1 0, perfect. Mark it as an assignment. Cancel every 0 in that row. Every 0 is already cancelled. Exactly 1 0, mark it as an assignment. Cancel every 0 in that row. Done, done and done. Can I say all the zeros are either marked or cancelled? Yes. I'm quickly going to repeat the marking bit. Let's go first row. First row, exactly 1 0. Mark it as an assignment. Cancel every other 0 in that column. Second row, 2 zeros, cannot do anything about it. Third row, exactly 1 0. Mark it as an assignment. Cancel every other 0 in that column. Fourth row, already cancelled. Fifth row, 1 0. Mark it as an assignment. Cancel every other 0 in that column. Sixth row, 2 zeros, cannot do anything about it. Let's go column wise. 2 zeros already marked or cancelled. 1 0, mark it as an assignment. Cancel every 0 in that row. Done. 1 0, mark it as an assignment. Cancel every other 0 in that row. Done, done and done. All the zeros are exhausted, which means all the zeros are either marked or cancelled. So all the zeros are either marked as an assignment or cancelled out. How many assignments did you get? Well, I got 1, 2, 3, 4, 5 assignments. How many were you supposed to get? 6. So is there a row without an assignment? Yes. Row number 4 did not get an assignment. Or if you want to look at it that way, column F did not get an assignment, either or. Which means that optimal assignment is not reached, which means that I will have to continue this by drawing lines. So to draw lines, I can draw lines here only. I don't want to mess it up. I'm going to draw a new table. So again the same, A, B, C, D, E, F, 1, 2, 3, 4, 5, 6. 16 0 0, 8 3 52, 40 0, 5 6 7 3, 4 17, 23 1 3 0, 27 43, 24 15 0 3 0, 0 59 5 0 4 21 26 28 5 6 7 0. Let's begin again. Row wise. Exactly one assignment. Cancel everything in that column. Two zeros, can't do anything. 1 0, mark it as an assignment. Cancel everything in that column. Done. 1, mark, cancel everything in that column. 2 zeros, cannot do anything. Let's start column wise. Already marked or cancelled? 1, 0. Perfect. Mark it as an assignment. Cancel everything in that row. It's already being cancelled. 1, 0. Mark it as an assignment. Cancel every 0 in that row. 1, 2, 3, 4, 5 assignments. I should have had 6. I didn't get 6. So now I have to draw minimum number of lines, cover the zeros, redefine the matrix, and then continue. Okay. How do you draw lines? So this step, I'm sorry, I forgot to write here. This is going to be step 4, drawing lines. How do you draw lines? Let's go back. This is how I draw lines. Number 1, mark a row that does not have an assignment. Number 2, in the marked row, mark a column that has a 0. Number 3, in the marked column, mark a row that has an assignment. And now keep repeating 1 and 2. So keep this on your side. I can't do that because I'm already trying to use the screen as much as I can. So I don't want to put the paper anywhere else. Anyway, to begin with, mark a row that does not have an assignment. Has an assignment, has an assignment, has an assignment, does not have an assignment. Mark. Is there any other row that does not have an assignment? No. Just one row that does not have an assignment. In the marked row, which means this is the marked row, mark a column that has a 0. Is there a 0 in this row? Yes, here. Then mark that column that has a 0. In the marked column, mark a row that has an assignment. So in this column, is there an assignment? Yes. Where? Here. Then mark that row that has an assignment. Now go back to step 2. In the marked row, mark a column that has a 0. Is there a 0? What do you mean by 0? 0 is a cancelled out 0? No. That's it then. You are done. I'm going to repeat this once again for you. Step 1. Mark a row that does not have an assignment. So this is the row that does not have an assignment. In that marked row, mark a column that has a 0. This is the 0. Mark the column that has a 0. In the marked column, mark a row that has an assignment. Well, this is the assignment. So this is the row that I have to mark. In the marked row, mark a column that has a 0. There is no more 0. This is it then. Draw lines through unmarked rows and marked columns. Well, I am going to do the final marking once again with a sketch pen so that it's fairly visible to you all, and then I'm going to draw lines. Mark a row that does not have an assignment. Well, this is the row that does not have an assignment. In the marked row, mark a column that has a 0. Well, this is the 0 and this is the column that has a 0. In the marked column, mark a row that has an assignment. This is the assignment. Mark this row. Draw lines through unmarked rows and marked columns. Okay. Unmarked row. This is an unmarked row. This is an unmarked row. And this is an unmarked row. Marked column is going, there is one more unmarked row. So this is the unmarked row. And marked column, well, this is going to be the marked column. Question number 1. Are all the zeros covered? Yes. There is no 0 that is left uncovered. All the zeros are covered. Question number 2. You had to do this with minimum number of lines. Have you done it with minimum number of lines? Well, who defines what the minimum number of line is? Simple. How many assignments did you get? 5. You were supposed to get 6, but you got 5, no? Then you should have covered all the zeros in 5 lines. Check. 1, 2, 3, 4 and 5. Yes. Well, if you're done, we can start redefining or redesigning the given matrix. How are we going to do that? Question number 1. Select or first identify the 3 elements. Uncovered, single line covered and junction, which is double line covered. Select the least from the uncovered. Well, this is the least, 1. The least cannot be 0 because all zeros are covered. This one will be subtracted from the uncovered. They will be added to the junction, no matter what the junction is. They will be added to the junction. And lastly, you will leave the single covered alone. You will not touch them. So once the drawing of lines is done, I'm going to go to step 5. What is step 5? Changing the matrix or redesigning the matrix. How? 1, 2, 3, 4, 5, 6, A, B, C, D, E and F. 1 is the least. Let's start from here. 16 uncovered minus 1 is going to be 15. 40 minus 1, 39. 4 minus 1, 3. 27 minus 1, 26. 0 is single covered, don't touch it then. 26 minus 1 is 25. Let's come to the next row. 0 single covered, 0 single covered, 0 single covered, 17 single covered, 43 single covered, 59 is at the junction. Then I will add the 1 to the 59 and 59 will become 60. 28 single covered, untouched. 3, 0, 5, 23, 24. Junction will be 6 and 5. 8 uncovered, 7. 6 uncovered, 5. 1 minus 1, 0. 15 minus 1, 14. Single covered, 0. 6 minus 1, 5. Single covered, 3. Single covered, 7. Single covered, 3. Single covered, 0. 4 at the junction. Add 1 and make it 5. No matter what is there at the junction. Remember one thing. Sometimes at the junction, you get a 0 also. Even if you get a 0, you have to add. Add whatever the least is. 7 single covered, untouched. 52 single covered, 3 single covered, 0 single covered, 30 single covered, 21 junction, 22, 0 single covered. After this, most of the times it is not required, but I would request you to check if a row and a column reduction is required. So, has a 0, yes, 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 yes and yes. Column, yes, 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 yes and yes. So every row and every column has a 0. Then I don't need to row and column reduce. Now I know technically what we are supposed to do is we are supposed to make a new. What I would want you to do is make a new matrix for assignment. So go to step 6, assignment, and draw the same matrix and assign it. My problem is then I'll have to keep turning pages because assignment will go here. I don't even know if it fits here because I need at least 1, 2, 3, 4, 5, 6, 7, 8, 9 lines, and I don't think I have that. 1, 2, 3, 4, 5, 6, 7. I only have 7 lines. So that is why what I'm doing is I'm assigning in the same matrix. Let's begin. 1, 0. Mark it as an assignment. Cancel every other 0 in that column. Fantastic. 2 zeros cannot do anything. 1, 0. Mark it as an assignment. Cancel every other 0 in that column. 1 0, mark it as an assignment, cancel every 0 in that column. 1 0, mark it as an assignment, cancel every other 0 in that column. 1 0, mark it as an assignment, cancel every 0 in that column. I'm done row wise. Let's start column wise. Already marked or cancelled? 1 0, mark it as an assignment, cancel every 0 in that row. Marked or cancelled, marked or cancelled, marked or cancelled, marked or cancelled. How many assignments were you supposed to get? Well, at least 6 is what I need. How many did you get? 1, 2, 3, 4, 5, 6. Yes. Thank your stars that you got 6 assignments. No more remodification of the matrix required. This is your answer. I'm quickly going to repeat this once. So please pay attention. That is why I wrote always write light at the start so that I can write a little darker the second time. So first row, exactly 1 0, mark it as an assignment. Cancel every 0 in that column. 2 zeros, can't do anything. Third row, exactly 1 0. Mark it as an assignment. Cancel every other 0 in that column. Number 4, exactly 1 0. Mark it as an assignment. Cancel every other 0 in that column. Number 5, exactly 1 0. Mark it as an assignment. Cancel every 0 in that column. Number 6, exactly 1 0. Mark it as an assignment. Cancel every 0 in that column. You are done row wise. Let's start column wise. 2 zeros already marked or cancelled. 1 0, mark it as an assignment. Cancel every 0 in that row. All the zeros are marked or cancelled. Exhausted. How many assignments did you need? 6. Do you have them? Yes. 1, 2, 3, 4, 5 and 6. What's your answer? Well, my answer is 1, 2, 3, 4, 5 and 6. And my answer is 1 is going to E. 2 is going to B. 3 is going to A. 4 is going to C. 5 is going to E. And 6 is going to F. Go back to your original and write the respective values there. So I'm writing it directly, I'm not showing it to you. 1 going to E is 5. 2 going to B is 9. 3 going to A is 2. 4 going to C is 18. 5 going to E is 5. And 6 going to F is 0. That's it. What is the total? Well, the total is, in your calculators, 5 plus 9 plus 2 plus 18 plus 5 plus 0 is a total of 39. So I guarantee you that this is the most minimum. There will be no other assignment that will give you a total less than 39. And that is how you solve an assignment problem. Let's move on to the next question. Before we move on to the next question, this is how the assignment problem is going to look or needs to look in totality. Let me just zoom in a little. I hope this should be good. Yes. I'm doing it on one page because and dividing into 2 halves because I want to make sure that I can show you everything. You can do it on 2 pages, no problem. Always try to do it on a double page so that just in case you require any referring, you don't have to keep turning pages. So that is one thing that you can keep in mind. Anyway, do the preliminary check. After that, row reduction, column reduction, assignment. If you get an assignment, which is if you have 5 rows and 5 columns, get 5 assignments. 6 rows, 6 columns need to get 6 assignments. If you get 6 assignments, nothing like it. If you don't get 6 assignments, draw lines, redesign the matrix and then assign again. And this is going to be the final answer. Before, like I said, before I move on to the next set of questions, I want to show you something or I want to discuss something. Just one second. I think I realize I make a mistake here. 5 is going to D and not to E. I wrote E twice. Sorry. So this should be D. I'm extremely sorry. 5 is going to D and not to E, and 5 on D is 1. Sorry. So the total will be 4 minus and then add 1, 35. I'm so sorry about that. I made that mistake. I wrote that 5 is going to E, but 5 is going to D, 1 is going to E. Sorry about that. Please make that change. Now, before I continue, like I said, I want to discuss the method of solving an assignment problem, so that once you have it with you, or once you have, you know what is supposed to be done, then I'm obviously going to share this with you, because now we've done every aspect. We can now discuss. It's easier for me to discuss this after I have taught you everything, because before there are a few things that you won't even understand what they mean. But now that I have done everything with you, understanding becomes a little easier. So let's begin then. Assignment problem. The Hungarian method of solution of an assignment problem. Hungarian mathematician D. Koenig developed the most effective method for solving an assignment problem. Now, like simulation, this also has a story to it, but I don't want to drag the story. There were two people who designed assignment problems, two people together, and both were Hungarian. They came from Hungary. So they were Hungarian mathematicians, and then later they didn't, according to what I have read, basically, they didn't really register the method. The method was registered by a third mathematician, and he didn't know, or he wanted to register it on their name. And because there were two people, he registered it on the place that they were from, and he registered it on Hungary, and that is why it's called the Hungarian method of solving an assignment problem. So, Hungarian mathematician D. Koenig developed the most effective method for solving an assignment problem involving minimization technique. Very important. This method that we study can only minimize, cannot maximize. Okay? Basic principle. So what principle does this work on? Well, the principle that it works on is, a Hungarian method is based on the following properties. Number one, if a constant element is added or subtracted from every element of any row or column in a given cost matrix, then an assignment that minimizes the total cost in the original matrix also minimizes the total cost in the revised matrix. And these are the kind of technicals that I was telling you that if I would have done this before, you wouldn't understand it. You know, remember I told you that if I reduce the entire row by 10, if I add 5 throughout, if I multiply the entire row by 4, if I divide the entire row by something, the best value changes, but the best position remains the same. Initially, whatever was the best still remains the best. That assignment of the best doesn't change, no matter how much you scale it up or scale it down by. And that is the principle on which this method works. The second thing that they said is, in an assignment problem, a solution that having zero cost is the optimal solution. Remember I told you that if you got only 4 assignments, but you were supposed to get 5, then there will be 1 row and 1 column pending. No, give it whatever is remaining. You can't do that. If you give it whatever is remaining, you are giving it a value which is not 0. You are assigning a value which is not 0. So the total of the assignment there will not be 0. And if the total of the assignment is not 0, then it is not an optimal assignment. And that is why they have said that in an assignment problem, a solution having 0 total cost is the best or the optimal solution. If the total cost is not 0, then it is not optimal. Like for example, this one right here that I did like just 2 minutes ago. If you look at this solution right here, 4 doesn't get anything. But the only thing remaining is F. Why don't you give 4 to F? If I give 4 to F in this matrix, the total will be 0 plus 0 plus 0 plus 6 plus 0 plus 0, which is the total of 6. Is the total cost 0? No. Then it is not optimal. Obviously, like I said, nobody really asks you all these things, so it doesn't really matter. Let's go back. Next, Assumption. So there are a few assumptions that you make in an assignment problem. Number one, each facility is capable of performing each task. This I told you. Every man is capable of working on every machine. Every horse is capable of riding. Every jockey is capable of riding every horse. Every driver is capable of driving every car. Every sales person is capable of going to every sales locality. Number two, only one task can be assigned to each facility. One-to-one assignment. One to many, not allowed. Many to one, not allowed. One person can't do two jobs and two people cannot do one job. As only one task can be assigned to each facility, the assignment matrix must be n cross n. Now, because only one task can be given to one person, the assignment should be an n cross n, which is 3 by 3, 3 rows, 3 columns, 4 rows, 4 columns, 5 rows, 5 columns, 10 rows, 10 columns. In case the matrix is not square, which is n cross n basically, dummy rows or columns may be added. If you've done mathematics 11th and 12th, you've done a chapter called matrices. This is not exactly matrices, but when values are written in rows and columns, we call it a cost matrix, is what we call it. And because we call it a matrix, remember in matrices, where numbers are written in rows and columns, the first classification of matrices is square matrix and rectangular matrix. In a square matrix, number of rows and number of columns is equal, while in a rectangular matrix, number of rows and number of columns is not equal. For you to be able to solve an assignment problem, your cost matrix should be a square matrix. Done? That is assumption, number, and now the Hungarian method of assignment problem minimization case can be summarized in the following steps. Number one, express the problem in an n cross n assignment matrix. Number two, select the smallest element from each row and subtract it from every element of that row. Number three, in the reduced matrix obtained from step 2, which is after row reduction, this basically for us is row reduction. In the reduced matrix obtained from step 2, select the smallest element from each column and subtract it from every element of that column. So row reduction, column reduction. Step 4, assignment. How do you make an assignment? Make the assignment of the reduced matrix obtained from step 2 and 3 in the following way. Examine the rows successively until a row with exactly one unmarked 0. So you need to have exactly one 0, and that 0 should be unmarked, which means it should neither be marked as an assignment and nor should be cancelled. There should be exactly one such 0. Okay. Make an assignment in this single 0 by putting a box. So this is what we put around it. I'm sorry. This is what you put around it. You put a box around it. And cross out, which is put a cross around all the zeros appearing in the corresponding column. When you're going row wise, you mark an assignment, cancel every 0 in that column, as they will not be considered for further assignment. Because if B is given to, let's say, 3, then 3 can't go to anybody else. So you cancel every other 0 in that column. Proceed in this way until all the rows have been examined. So you keep doing this till all the rows have been examined. After you are done doing this row wise, you come to doing the same but column wise. After examining all the rows completely, examine the columns successively until a column with exactly one unmarked 0 is found. Make an assignment to this single 0 by putting a box. Again the same, you do this column wise. Around it and cross out all the zeros appearing in the corresponding row. So when you are going row wise, you are cancelling every 0 in the column. When you are going column wise, you will cancel every 0 in the row, as they will not be used to make another assignment in that row. Proceeding in this manner Proceed in this manner until all the columns have been examined. So do this till you have exhausted all the columns also. And now, if there are still zeros that are pending, repeat the operation 1 and 2 successively until one of the following situation arises. So keep doing this. Keep doing this until one of the two things happen. Number 1. All the zeros in the rows and the columns are either marked in a box or crossed out, which is cancelled, and there is exactly one assignment in each row and each column. So keep doing this till there is exactly one assignment in every row and every column. Or in other words, the number of rows and number of columns is equal to the number of assignments. In such a case, optimum assignment policy for the given problem is obtained, or optimal assignment is obtained. If that doesn't happen, then B. There may be some rows or columns without an assignment. Could happen, we saw that. That is, the total number of marked zeros is less than the order of the matrix. Such a case, proceed to step 5. What according to us did we do? Well, we drew number of lines. We drew minimum number of lines and we covered all the zeros. That is exactly what we are going to do. Number 1, mark, which is tick mark, all the rows that do not have an assignment. Okay, so you tick mark all the rows that do not have an assignment. So number 2, mark all the columns not already marked which have zeros in the marked rows. So how did I write it? I wrote it as, in the marked row, mark a column that has a 0. It's the same way they've written it in an active passive voice. Mark all the columns which have zeros in the marked rows. Mark all the rows that have an assignment in the marked columns. So according to me it was, mark a row that does not have an assignment. In the marked row, mark a column that has a 0. In the marked column, mark a row that has an assignment. After that what? Repeat step 2 and 3 over and over again. So repeat step 5, 2 and 3 until no more rows or columns can be marked. Okay. Number 5, draw straight lines through unmarked rows and marked columns. Done. It may be pointed out that one may draw minimum number of lines to cover all the zeros by inspection. I want you to ignore this for the time being. Come to step 6. The number of straight lines drawn in step 5 is equal to the number of assignments achieved in step 4. Now go to step 7. Remember I told you this? You have to cover all the zeros by drawing minimum number of lines. Who defines or who decides what the minimum number of lines are? Well, the number of assignments should be the number of lines. We go to step 7. Select the smallest element among the uncovered elements. Subtract it from the smallest element. Subtract this smallest element from all the uncovered elements. Add it to the elements which lie at the intersections intersection of two lines. Thus, we obtain another reduced matrix for fresh assignment. So, what did I tell you? You will select the smallest from the uncovered, subtract it from the uncovered, add it to the junction and leave the single covered alone. That is why they haven't mentioned anything about the single covered. Step number 8. Go to step 2. Oh, what is step 2? Step 2 was row reduction. Correct. After redefining the matrix, we have to go back to row reduction, column reduction and then assignment. Go to step 2 and repeat the procedure until number of assignments become equal to number of rows and number of columns. In such a case, we shall observe that each row and column has an assignment. Thus, the current solution is an optimal solution. Step 9. The optimal assignment schedule corresponding to assigned zeros obtained is noted down. Step 10. Optimal cost can be obtained by adding the cost at the assigned points in the cost matrix. Done. These are the 10 steps. After that, there is something called as special cases. You know what these special cases are? Well, these special cases for me, some part is my preliminary check. I will give you in writing as to how I solve how I look at my assignment problem. Special case in assignment problem number 1, maximization objective. Sometimes there may be situations where the objectives of assignment is maximization of output, profit or sales, etc. Assignment model is essentially a minimization technique. To solve a problem of maximization objective, all the elements in the matrix are subtracted from the largest element in that matrix. Remember, we pick up the most maximum value and subtract it from everybody else. That is how we get an opportunity cost or an opportunity lost matrix. There's another choice which I don't prefer, and I would suggest you also not to prefer. Or alternately, all elements in the matrix are multiplied by 1. Oh, what is this? Well, simple. See, when you suppose you have 5 and you have 4, or you have 5 and you have 1. Technically, which is smaller? 1 is smaller. But in maximization, I need 5 as the answer. So assignment problem chooses 1, doesn't choose 5, because assignment minimizes. What you do is you multiply by -1. When you multiply by -1, what happens? 5 becomes -5, 1 becomes -1. Between -1 and -5, who is smaller? -5 is smaller. Now assignment will choose -5. But my problem is, no, with that negative sign and then reduction, everything goes a little haywire. I would suggest don't do it. I would suggest stick to our method, select the most maximum, subtract it from every other element and continue. Done. What after that? Then solve the problem with the reduced matrix as per the method of minimization of assignment problem. Okay, that is one. Maximization objective. Unbalanced assignment problem. An unbalanced assignment problem is the one in which the number of tasks and facilities are not equal. That is, or to each other. That is, payoff matrix, which is basically your cost matrix, of an assignment problem is not a square matrix. Number of rows is not equal to number of columns. An unbalanced problem can be balanced by adding dummy tasks / facilities with 0 costs. So you add a dummy row or a dummy column with 0 costs, such that resulting matrix as per the method of minimization in an assignment problem. So now the resultant matrix can be solved as per the method of minimization in an assignment problem. The next thing is a prohibited assignment. This also I told you. An assignment problem involving restriction in allocation can be solved by assigning a very high cost, say infinity, to that prohibited entries. Like I told you, I don't prefer doing that. I prefer just putting a dash or an infinity sign and continuing. And the last is multiple optimal solutions. I did one question with you with multiple optimal solutions. Alternative multiple optimal solutions exist in assignment problem when the final assignment matrix contains more than the required number of 0 elements. Now, when there are more than required number of 0 elements, or when you are assigning, you keep going in a loop. You can't cancel a 0, you can't select a 0. And that is where you randomly select any one 0 and mark it as an assignment. Cancel the zeros in that row and that column and then mark the diagonally opposite. And this is the procedure or the method to solve an assignment problem. I don't like discussing this, or I didn't want to discuss this before, for a simple reason that there are a lot of things that you won't even understand if I discuss this before teaching it. Now that I've taught it, I hope it was easier for you to register what means what and how you are supposed to go by it. This is it. Let's continue with questions. What I'm going to do now is quickly write down my method of solving an assignment problem, or what all do I check while solving an assignment problem. So the steps involved while I solve an assignment problem is, number one is I always do a preliminary check. What do I do in the preliminary check? Well, preliminary check number one, objective. What do I check in this? Is the objective minimization or the objective is maximization? If it is minimization, okay. If it is maximization, not okay, change it to a minimization objective. Check number two, balance. That is, if number of rows is equal to number of columns. If yes, fantastic. If no, make sure this happens. Number three, and the last one, is there any prohibition? Is there any prohibited assignment? Sometimes they don't tell you in the table, they give you a value in the table, but then verbally they write it down that this assignment is not allowed. So make sure you incorporate that prohibition. After that, you start with the Hungarian method. In that, step one is row reduction. Step two is column reduction. Step three is assignment. Here, if number of rows, which will always be equal to number of columns, is equal to number of assignments, then optimal assignment is reached. You have an optimal assignment. But what if this does not happen? Or draw lines. I have written down draw lines. Draw lines through unmarked rows and marked columns. How? Drawing lines. Mark a row that does not have an assignment. In the marked row, mark a column that has a 0. In the marked column, mark a row that has an assignment. Repeat 2 and 3 till all the rows are either marked or cancelled. And after doing that, draw lines through unmarked rows and marked columns. There will be 3 types of elements: uncovered, single covered and junction elements. Select the least from the uncovered, subtracted from the uncovered, add it to the junction and leave the single covered alone. After that, you go back, row reduction, column reduction, assignment. If you get the required number of assignments, fantastic. If not, you keep doing this in loops till your number of rows, number of columns and number of assignments is the same. That is it. You have the procedure. Let's finish off whatever questions that are left in the sheet. Let's come back to the sheet. I think I did question number 15. Yes. Let's move on to question number 16 then in that case. Question number 15 was done. This is question number 15. Solve the minimization problem. Fantastic. Objective is to minimize. 5 rows and 5 columns. Fantastic. Is there a prohibition? Not mentioned. Fantastic. So preliminary check is done. I can directly start solving. Let me write down the matrix. Now from here on, I would suggest you that you copy the question, try it yourself. So I would suggest, or when I'm in class, this is what I do. I ask you to start doing the question, you know, up till where? Up till assigning. Or one step at a time. Row reduction, check your and my row reduction, check your and my column reduction. Step 3, assignment. You do the assignment, then wait for me to do it and check it. Now, because this is happening over a video, you can pause wherever you want to and then check your and my solution. Now, I've drawn vertical lines because the numbers are very big. Next, I will write them slightly spaced out so that it's easier for us to identify. So what I would suggest is, I would suggest you do row reduction, column reduction and assignment. Stop. Check if I get the same assignment. And like I told you, I'm doing questions where you will never get a final answer in the first go. You will have to draw lines. So row reduction, column reduction, assignment, you will not get an answer, but stop. Wait for me to reach there, check. After that, pause the video again, draw, do the tick marking, stop, check if my tick marking is the same, unpause, check if the lines are the same, redesign the matrix, check if your and my redesigning is the same, and then continue. So, since the objective is to minimize, am I right? Yes. The number of rows and the number of columns is equal. Yes. And there is no prohibition. So the preliminary check is done. Then can I say I can directly start off with step 1, and that is row reduction. What am I going to do in row reduction? Well, 1, 2, 3, 4, 5, A, B, C, D, E. Select the least from every row and subtract it from every other element in that row. The least, if I'm right, is 130. So when I do a row wise reduction, 160 minus 130 is 30. 130 minus 130 is 0. 175 minus 130. My calculator should be 45 if I'm right. 175 minus 130 is 175 minus 130. 175 minus 130 is 45. 190 minus 130 should be 60, and 200 minus 130 should be 70. Let's go to the next row. The least here I think is 120. 135 minus 120 is 15. 120 minus 120 is 0. 130 minus 120 is 10. 160 minus 120 is 40. 175 minus 120 is 55. 175 minus 120 is 55. Perfect. The least here is 110. 140 minus 110 is 30. 110 minus 110 is 0. 155 minus 110 is going to be 45. 170 minus 110 is going to be 60, and 185 minus 110 is going to be 75. The least in the next row is 50. 50 50 is 0. 50 50 is 0. 80 50 30. 80 50 30. 110 50 is 60. And lastly, the last row, the least is 35. 55 minus 35 is 45, 55, 20, 35, 35 is 0, 70, 35 is 35, 80, 35 is 45 if I'm right, 80 minus 35 is 45, perfect, and 105 minus 35 is 70, correct. So, step 1 row reduction is done. Step 2 column reduction if required. Well, let's check if it is required. Column number 1 has a 0, column number 2 has a 0, column number 3 does not have a 0. So even if one column doesn't have a 0, you have to do a column reduction. So step 2, column reduction. A, B, C, D, E, 1, 2, 3, 4, 5. The first column already has a 0, so 30, 15, 30, 0, 20, 0, 0, 0, 0, 0, 10. So 35, 0, 35, 20, 25. The least here is 30, 30, 10, 30, 0, 15. The least in this column is 55. So 15, 0, 20, 5 and 15. Row and column reduction is done. We move on to the third step. Technically, if everything goes well, ideally should be the last step. But let's see if our stars are on one side. Step 3, assignment. So, A, B, C, D, E, 1, 2, 3, 4 and 5. Let me write it down as and how it is. 30, 15, 30, 0, 20, 0, 0, 0, 0, 0, 35, 0, 35, 20, 25, 30, 10, 30, 0, 15, 15, 0, 20, 5, 15. Let's start assignment. Now for assignment, let me zoom this in a little. So let's start the assignment. Let's start row wise. Row wise exactly 1 0. Very nice. Mark it as an assignment. Cancel every other 0 in that column. Second row, 2 zeros, can't do anything. Third row, 1 0 already cancelled. Fourth row, 2 zeros, can't do anything. Fifth row, 1 0 already cancelled. Let's start column wise. Column wise exactly 1 0. Mark it as an assignment. Cancel every 0 in that row. Column wise all zeros are marked or cancelled. Column wise 1 0. Mark it as an assignment. Cancel every 0 in that row. Column wise 1 0 already cancelled. Column wise 1 0 already cancelled. Oh. If you notice, we got only 3 assignments. 1, 2 and 3. All the zeros are exhausted. We wanted 5. We are not even close to where we are. So if we got 5, if we wanted 5 but we got only 3, it means optimal assignment is not reached. And we will have to draw lines. So since number of rows and columns is not equal to number of assignments, optimal assignment is not reached. Then what do? We move on to step 4, and that step 4 is drawing lines. So I go to step 4, drawing lines. Now technically you can draw lines in this. I don't want to, or I would suggest that you don't draw the entire matrix again. So I'm drawing the entire matrix again. So I have 1, 2, 3, 4 and 5, A, B, C, D, E. Correct? Let me write it down. 30, 15, 30, 0, 20, 0, 0, 0, 0, 0, 35, 0, 35, 20, 25, 30, 10, 30, 0, 15, 15, 0, 20, 5, 15. Now I'm going to quickly assign in this also for you, so that once again I didn't show it to you twice there, so I'm going to show it to you twice here. Row wise exactly 1 0, mark it. Cancel every 0 in that column. 2 zeros can't touch. 1 0. 2 zeros can't touch. Already cancelled. Column wise exactly 1 0, mark it. Cancel every 0 in that row. Already cancelled. Exactly 1 0. Cancel every 0 in that row. Like I said, we only got 3 assignments when we should have gotten 5. So then optimal assignment is not reached. We will have to start drawing lines. Step 1, mark a row that does not have an assignment. So mark a row that does not have an assignment. Now this row has an assignment, this row has an assignment, this row does not have an assignment. This row has an assignment, this row does not have an assignment. There are 2 rows that don't have an assignment. So now you need to, in the second step, which is in the marked row, mark a column that has a 0. You have to examine 1 row at a time. Is that correct? So in the first step, mark a row that does not have an assignment, 2 rows that do not have an assignment. In those marked rows, I have to mark columns. Which columns? Columns that have a 0. Okay. So in the marked rows, I have to mark columns that have a 0. Where is the 0? Here. So I will mark this column. Okay. In the marked row, mark a column that has a 0. Where is the 0? Here. Well, it's already marked. Fantastic. Now, do you realize that we have to analyze 2 rows? Now, luckily for us, both the rows had a 0 in the same column. Okay. If this one had a 0 here, I would mark it here. No problem. Step 3. In the marked column, mark a row that has an assignment. In the marked column, mark a row that has an assignment. This row has an assignment. Mark this. Now, go to step 2. What was step 2? In the marked row, mark a column that has a 0. In the marked row, mark a column that has a 0. Well, there is no 0. Then it's done. But now I'm going to repeat it and I'm going to show you something else that you should do along with the marking. And that is, when there is multiple markings, try to cancel out the tick mark that is already examined so that there is no confusion. And that is, I'll tell you, mark a row that does not have an assignment. Well, there are 2 rows that do not have an assignment, 1 and 2, row number 3 and row number 5. In the marked row, so let's examine this first. In the marked row, mark a column that has a 0. In the marked row, mark a column that has a 0. Which column has a 0? This one. Mark it. Are you done examining this row? Yes. Cancel it out because that examination is done. So if there is more marking in the rows, I don't have to again examine this because I know I have examined this. Let's come to examining this. In the marked row, mark a column that has a 0. Well, this is the same column that has a 0. Fantastic. Examination done. In the marked column, mark a row that has an assignment. That is step 3. In the marked row, mark a column that has an assignment. Well, in the marked column, mark a row that has an assignment. Well, in this marked column, this is the assignment. So this row will get marked. Cancel this out because the examination is done. Go back to step 2. And what was step 2? Well, step 2 was in the marked row, mark a column that has a 0. In the marked row, mark a column that has a 0. Is there a 0? No. There is an assignment. So you are done. Examination done. And your marking is done. Draw lines through unmarked rows and marked columns. So I'm going to do this one last time quickly and then draw lines. So step 1, mark a row that does not have an assignment, has an assignment, has an assignment, does not have an assignment, has an assignment, does not have an assignment. In the marked row, mark a column that has a 0. Well, here there is a 0. Then mark this column. Done examination. In the marked row, mark a column that has a 0. Well, this is the column that has a 0, but it's already marked, so no need to remark again. In the marked column, mark a row that has an assignment. Well, in the marked column, a row that has an assignment. This is the assignment, so this row. Done examination. In the marked row, mark a column that has a 0. There is no 0. There is one assignment. Done then. Draw lines through unmarked rows and marked columns. What are your unmarked rows? Well, this row number 2 was an unmarked row. Row number 4 is an unmarked row. And there is one marked column, and that is column B. Unmarked rows and marked columns. Question number 1. Have you covered all the zeros? Yes. Nowhere do I see a 0 in the open. Well, fantastic. Question number 2. How many lines have you done it in? Well, I have done it in 3 lines. Are these minimum number of lines? Well, I don't know. Who decides that? Simple. How many assignments did you get? 3. Then in 3 lines, everything should be covered. Done? We redesign the matrix. How? Select the least from the uncovered. The least here is 15. Then there is no other number lesser than 15. Then any 15 you can pick up. 15 is the least. Subtract that 15 from the uncovered. Add it to the junction and leave the single covered alone. Okay, so starting from here, step 5, redesigning the matrix. How do you redesign the matrix? 1, 2, 3, 4, 5, A, B, C, D, E. 15 is the least. 30 is uncovered, subtract. 30 minus 15 is 15. 0 is single covered, remains as and how it is. 35 minus 15 is 20. 30 minus 15 is 15. 15 minus 15 is 0. 15 is single covered, don't touch. 0 is at the junction, and I told you, you will not treat zeros any differently. If it is at the junction, you will add. 0 plus 15 is 15. Single covered, leave it alone. Single covered, leave it alone. Single covered, leave it alone. 30, uncovered, subtract. 15, 0, single covered, leave it alone. 35, uncovered, subtract. 20, 30, uncovered, subtract 15. 20, uncovered, subtract 5. Single covered, 0. Junction, add 15. Single covered 20, single covered 0, single covered 5. 20 minus 15 is 5. Single covered 0. 25 minus 15 is 10. 15 minus 15 is 0. 15 minus 15 is 0. This is your new redesigned matrix. Step 1 row reduction, step 2 column reduction, if at all required, assignment. Check row reduction. Every row already has a 0. Fantastic. Column reduction. Every column also has a 0. Well, then let's go to step 6. Step 6 is going to be assignment. Let's start the assignment. I'm not doing it in this. I'm writing or drawing a new table. So I have 1, 2, 3, 4, 5. That's it. And A, B, C, D, E. 15, 15, 15, 0, 5. 0, 15, 0, 15, 0. 20, 0, 20, 20, 10. 15, 10, 15, 0, 0, 0, 0, 5, 5, 0. Let's start the assignment. Row wise. 2 zeros cannot do anything. 2 zeros cannot do anything. 1 0. Fantastic. Mark it as an assignment. Cancel every zero in that column. Let's go to row 4. 2 zeros cannot do anything. 2 zeros cannot do anything. Let's go column wise. 1 0. Mark it as an assignment. Fantastic. Cancel every other zero in that row. Already marked or cancelled. 1 0. Mark it as an assignment. Cancel every zero in that row. 1 0. Mark it as an assignment. Cancel every zero in that row. And lastly 3 zeros but 2 are cancelled. So technically 1 0. Mark it as an assignment. Are all rows and columns exhausted? Yes. All zeros are exhausted? Yes. What do you notice? Well, I noticed that I have 5 assignments and that is exactly what I required because I have 5 rows and 5 columns. Optimal assignment is reached. Thank your stars. This is your answer. I'm going to reassign once again, quickly, one last time so that you get a clearer answer. Row wise, 1 0. Mark it as an assignment. Sorry. Row wise, 2 zeros cannot do anything. Okay. Row wise, 2 zeros cannot do anything. Row wise, 1 0. Perfect. Mark it as an assignment. Cancel every zero in that column. Row wise, 2 zeros cannot do anything. Row wise, 2 zeros cannot do anything. Column wise. First column, exactly 1 0. Mark it as an assignment. You are going column wise. Then cancel every other zero in that row. Already marked or cancelled? Exactly 1 0. Mark it as an assignment. Cancel every other zero in that row. Exactly 1 0. Mark it as an assignment. Cancel every zero in that row. Exactly 1 0. Mark it as an assignment. Cancel every zero in that row. I had 5 rows and 5 columns. I have 5 assignments to show for it, which means that optimal assignment is reached. So, since number of rows and columns is equal to number of assignments, optimal assignment is reached. And what is that optimal assignment? 1, 2, 3, 4, 5. Okay, let me start here. 1, 2, 3, 4, 5. 1 here goes to E. 2 goes to C. 3 goes to B. 4 goes to A. And 5 goes to D. From the original matrix, which is this, let's pick up the values. When 1 goes to E, the answer is 200. 2 goes to C, the answer is 130. 3 goes to B, the value is 110. 4 goes to A, the answer is 50. And 5 goes to D, the answer is 80. The total of this is 200 plus 130 plus 110 plus 50 plus 80, and the answer is 570 at the most minimum. And this is your answer, and this is a solution of an assignment problem, or this is how the solution of an assignment problem should look. This still doesn't fit. Preliminary check, row reduction, column reduction, assignment. If you get the number of assignments, fantastic. If not, you redesign the matrix by drawing lines, draw lines, redesign the matrix, row reduction, column reduction if required. A lot of times it is not required. Assignment. That's your answer. Let's move on. Let's come to one last question from the sheet, and then we'll see what we have to do after that. So we stopped at question number 16. The one last question that is left is question number 17. Solve the following minimization problem. So it's a very basic problem. All you have to do is minimize. Fine, I will quickly get the basics ready, which is draw the table and all of that. So this is the table given to you. They want you to minimize it. Fantastic. So I don't even need to ask you what the objective is. The objective is minimization. Okay. So for the preliminary check, the first answer is answered. Question number 2. In this problem, is there any imbalance where number of rows, number of columns are equal? Yes. So number of rows and number of columns are also equal, balanced. Question number 3 and the last question. Is there any prohibition? Well, nobody's mentioned any prohibition, so no. Then we move on to step 1, row reduction. Step 1, row reduction. So this is going to be A, B, C, D, E, 1, 2, 3, 4, 5. Row number 1, the least is 2. Start subtracting. 3, 0, 2, 0, 4. Least is 1, 2, 3, 0, 4, 6. Least is 1, 5, 2, 2, 0, 1. Least is 2, 2, 0, 0, 1, 3. And least is 3, 0, 3, 1, 4, 0. Row reduction is done. If every column also has a 0, fantastic. If not, column reduction will be required. Let's come to column reduction. First column has a 0. Second column has a 0. Third column has a 0. Fourth column has a 0. Fifth column has a 0. Every column has a 0. Well, then if every column has a 0, there is no need for column reduction. So let's just mention it quickly and say, since every column already has a 0, column reduction is not required. So then what do I do? Well, then step 2 directly becomes assignment. So I will now say then there is step 2 is directly assignment. So I will say A, B, C, D, E, 1, 2, 3, 4, 5. Now if column reduction is not required, let me write it down as and how it is. 3, 2, 5, 2, 0, 0, 3, 2, 0, 3, 2, 0, 2, 0, 1, 0, 4, 0, 1, 4, 4, 6, 1, 3, 0. Let's start with assignment. Let me do one thing. Let me zoom in a little so that becomes easier. Let's begin row wise. 2 zeros, do not touch. 1 exactly 1 0, mark it as an assignment. Cancel every 0 in that column. Exactly 1 0, mark it. Cancel every 0 in that column. Exactly 1 0, mark it. Cancel every 0 in that column. 2 zeros, don't touch. Start going column wise. Exactly 1 0, mark it as an assignment. Cancel every 0 in that row. If you notice, all the zeros are exhausted. How many assignments did you get? 1, 2, 3, 4 assignments. How many should you have gotten? I should have gotten 5. Have you gotten the number of assignments that you need? Well, no. Then do one thing, go back and tell them that since number of rows and columns is not equal to the number of assignments, optimal assignment is not reached. What do we do now? We redesign the matrix. But what do you mean by redesign the matrix? First I draw lines and then I redesign the matrix. Okay, so let's write down the same matrix again to draw the lines. So I will do that with, so here I'm going to say step 1, 2, 3, step 1, 2, sorry, step 3. Now because I have to reassign here also, I'm going to reassign it for you. Row wise 2 zeros can't do anything. Row wise 1 0. Perfect. Mark it as an assignment. Cancel every 0 in that column. Row wise 1 0. Mark it as an assignment. Cancel every 0 in that column. Row wise 1 0. Mark it as an assignment. Cancel every 0 in that column. Row wise 2 zeros. Don't do anything because you are not allowed to touch. Go column wise. Column wise exactly 1 0. Mark it as an assignment. Cancel every 0 in that row. All zeros are marked or cancelled. Optimal assignment is not reached. So we are drawing lines. How? Step 1. Mark a row that does not have an assignment. If you want it in front of you, here it is. If it doesn't fit, let me unzoom a little. So, mark a row that does not have an assignment. Does not have an assignment? Fantastic. Has an assignment, has an assignment, has an assignment, and has an assignment. Okay. In the marked row, mark a column that has a 0. So, in the marked row, you want me to mark a column that has a 0. In the marked row, mark a column that has a 0. Where there is a 0 here and there is a 0 here. So, I have to mark 2 columns. So, number 1, mark this column. And number 2, mark this column. Now be careful and remember that once you've marked it, cancel this out because that analysis is done. Now come to the columns. In the marked column, mark a row that has an assignment. In the marked column, so let's do one column at a time. In the marked column, mark a row that has an assignment. Well, here there is an assignment, which means I will mark this row, cancel this. In the marked column, this is the marked column, mark a row that has an assignment. Well, this is the assignment, mark it. This is also done. Again, 2 rows marked, so I have to examine both. Let's start with this. In the marked row, mark a column that has a 0. I go back to step 2. In the marked row, mark a column that has a 0. Well, in the marked row, there is no 0. Fine then, done. In the marked row, mark a column that has a 0. Well, there is a 0 here. Then mark it. Cancel. In the marked column, mark a row that has an assignment. In the marked column, mark a row that has an assignment. This is the assignment. Mark this row then. This is done analyzing. In the marked row, mark a column that has a 0. Is there a 0? No. Then you are done. It's a very beautiful marking. A lot of people might find this cumbersome. So let me repeat this for you. Sorry. Mark a row that does not have an assignment. So, does not have an assignment. And yeah, just one row, done. Now after that we only have to repeat 2 and 3 over and over again. So, fine. In the marked row, mark a column that has a 0. This column has a 0. This column has a 0. Done. In the marked column, mark a row that has an assignment. So in this column, the row that has an assignment is this. This is the assignment. Then mark this row. Analyzing this column is done. In the marked column, mark a row that has an assignment. Well, in this column, the assignment is here. Then mark it. Analyzing this is done. Go back to step 2. In the marked row, mark a column that has a 0. Well, there is no 0 here. There is only an assignment. Then done. In the marked row, mark a column that has a 0. Well, there is a 0 here. Then mark it. Done. In the marked column, mark a row that has an assignment. Well, this is the assignment. Cancel. In the marked row, mark a column that has a 0. No 0. Done. Draw lines through unmarked rows. There is only one unmarked row left. And marked columns. There are 3 marked columns. Fine. Let's start. Unmarked row. Marked column. 1, 2, and 3. Question number 1. Are all zeros covered? Yes. I don't see any zeros in the uncovered. Fantastic. Question number 2. How many lines did you draw? Where I drew 4 lines. Well, was that okay? Yes. I had 4 assignments, no? If I had 4 assignments, then in 4 lines this should be covered. Fantastic. Now what? Now select the least from the entire matrix. Subtract it from the uncovered. Add it to the junction and leave the single covered alone. So the least is, I think there is a 1. This one will be subtracted from the uncovered, added to the junction, and the single covered will be left alone. Let's begin. Again, A, B, so redesigning the matrix, and this will be step 4. A, B, C, D, E, 1, 2, 3, 4, 5. 3 uncovered, 2. 2 uncovered, 1. 5 uncovered, 4. 2 uncovered 1, 0 single covered, untouched. Single covered, so 0, 3, 2, 0, 4. Single covered, so 2, 0, 2, 0, 1 will now become junction, so 2. This will be 0, 4, 0, 1. 4 is at the junction, will become 5. And uncovered, so 3, 5, 0, 2, single covered, so 0. Now what? Row reduction, column reduction, assignment. Row reduction, not required. Has a 0, has a 0, has a 0, has a 0, and has a 0. Column reduction, not required. Assignment, I can start assigning. Technically, like I said, we do it in a new table. What I'm going to do is I'm going to do here only so that we don't waste time. 2 zeros cannot do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. 2 zeros cannot do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. 2 zeros cannot do anything. Let's go column wise. 1 0, mark it as an assignment. Cancel every 0 in that row. 2 zeros already marked or cancelled. 2 zeros already marked or cancelled. 2 zeros cannot do anything. 1 single 0, mark it as an assignment. Cancel every 0 in that row. You did row wise, you did column wise. Still 1 0 remaining, then start row wise. 1 0, mark it as an assignment. Cancel every 0 in that column. Everything else is done. How many assignments did you get? 1, 2, 3, 4, 5. Fantastic. Thank your stars. And this is your answer. So your answer is going to be. What is your answer going to be? 1, 2, 3, 4, 5. And 1 is going to D. 2 is going to C. 3 is going to E. 4 is going to D. And 5 is going to A. If I have to write down the values, 1 going to D is 2, 2 doing C is 1, 3 doing E is 2, 4 doing B is 2, 5 doing A is 3. The total is 3, 4, 5, 6, 7, 8, 9, 10. It is done in a minimum of 10. Done? This is your answer. So if you notice, the only cumbersome part or the difficult part is the tick marking and the drawing of lines. Everything else is easy. What I want you to do is, I'm going to continue. Although this was the last question, I'm going to continue and I'm going to show you something which will make you cry. If this hasn't already made you cry. So I would again suggest take a 5-minute break, take a stroll somewhere and come back. Welcome back. So like I said some time ago, the most cumbersome part in this is the drawing of lines. Correct? So what I've done is I have written down the row and column reduced matrix, which is this, in which we make the assignment. And I know that we are not going to get an assignment, or we are only going to get 4 assignments instead of 5. So I have written down 3 matrix, same matrix, the same reduced matrix. I'm going to draw lines. And haven't we done this before? Step 1, mark a row that does not have an assignment. Sorry, we have to first do the assignment. So let's start doing the assignment. 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that column. Is that right? After that, 1 0. Mark it as an assignment. Cancel every 0 in that column. Then there is 1 0. Mark it as an assignment. Cancel every 0 in that column. 2 zeros can't do anything. Start going column wise. 1 0. Mark it as an assignment. Cancel every 0 in that row. Then you realize that this is not an optimal assignment. So we start drawing lines. How? Mark a row that does not have an assignment. Well, row number 1 does not have an assignment. In the marked row, mark a column that has a 0. Here there is a 0, so mark this column. And here there is a 0, so mark this column. Done? In the marked column, mark a row that has an assignment. In this column, here there is an assignment, then mark that row. Done. In the marked column, mark a row that has an assignment. Well, here there is an assignment, mark it. Done. In the marked row, mark a column that has a 0, there is no 0. In the marked row, mark a column that has a 0, this is the 0. Mark it. Done. In the marked column, mark a row that has an assignment. In the marked row, mark a column that has an 0. No 0. And then we draw lines through unmarked rows, which this is the unmarked row. Or to be safe, let me do this with a marker. We draw lines through unmarked rows and marked columns. Done? We finished doing this in 4 lines. Is that correct? Yes, because I had 4 assignments, no? So then I should have drawn 4 lines and covered all the zeros. Fantastic. I'm going to repeat this. And again, let's start assigning. 2 zeros can't do anything. 1 0 mark it as an assignment. Cancel every 0 in that column. 1 0 mark it as an assignment. Cancel every 0 in that column. 1 0 mark it as an assignment. Cancel every 0 in that column. 2 zeros cannot do anything. Let's go column wise. 1 0 mark it as an assignment. Cancel every 0 in that row. And now we draw lines. But some time ago, when I read the different ways of solving an assignment problem, I conveniently skipped a part. And I'll tell you what part I skipped. This is the question. I want the assignment problem solution. This part I skipped. What does that part say? It may be pointed out that here one may also draw the minimum number of lines to cover all the zeros by inspection. What do you mean by inspection? Is inspection some method? No. But what inspection means is that you can randomly draw lines and finish it off. There is no requirement of ticking. So what do you mean by inspection? Simple. This is your matrix. So what you are going to do is start drawing lines and covering the zeros. But how many lines? Well, here automatically 4 lines were drawn. But now because you are randomly drawing the lines, you need to know how many lines should I draw. Well, you should draw 4 lines and cover this up because you have 4 assignments. Now, how do you do this? This will be very instinct based. How you are supposed to do this is look at that row or that column that has most number of zeros and draw a line. So this row has 2 zeros, this has 1, this has 1, this has 2, this has 2, this has 1, this has 2, this has 2, this has 2 and this has 1. So most of the places you will see that there are 2 or 1 0. So usually what I do is I write it down 2, 1, 1, 2, 2 and here 1 0, 2 zeros, 2 zeros, 2 zeros and 1 0. Now everywhere, most of the places you see there are 2 zeros. Then randomly select any row or any column with 2 zeros and draw a line. What if I draw this line? Well, go ahead, draw this. 2 zeros are covered. 1 line down. You have 3 more lines left. In 3 lines, the rest should be covered. Okay. Can I do one thing? Can I say I want to draw a line here to cover these 2 zeros? Yes, no problem. 2 lines done, 2 more to go. Okay. So can I say there are 2 zeros here? Can I draw a line here? Yes, no problem. Oh, problem. I've already drawn 3 lines. There is only 1 line that is pending. Now to draw that 1 line, how can I cover these 2 zeros in different rows and different columns with 1 line? So I clean it and I start doing this again. And that is what you mean by inspection. Keep doing the trial and error till in exactly 4 lines you have covered all the zeros. So yes, it will be easier than this. But see, the thing about this is, once you get this into your basic, it's very easy. I find it very easy. And you also, if you practice that over and over again, you will also find this extremely easy. This will be a lot of trial and error till you realize what 4 lines exactly cover all zeros. Otherwise, then you will have to keep doing this a lot of times. So it's a lot of erasing and redoing, erasing and redoing. Well, there's another method, which is the third method, which can also be done. What is that? Let me zoom in a little and show it to you. And the third method is, and pay attention. With a pencil, you are assigning, right? So what happened was, you made an assignment. You realized optimal assignment is not being reached. So now you redraw the matrix in which you are going to draw lines because you know that optimal assignment is not reached. So this is what you are going to do for drawing the lines. 2 zeros cannot do anything. Fantastic. Move to the next line. 1 0. Oh, mark it as an assignment. Cancel every 0 in that column? No. Cancel the entire column only. Move on to the next row. 1 0. Mark it as an assignment. Cancel every 0 in that column? No. Cancel the entire column only. Exactly 1 0. Mark it as an assignment. Cancel every 0 in that column? Well, I don't care. I'm cancelling out the entire column. 2 zeros cannot do anything. Okay. Let's go column wise then. Column wise, exactly 1 0. Yes. Mark it as an assignment. And if you are going column wise, you will cancel the entire row. Do you notice that all zeros are exhausted and I have effectively drawn the lines also? And here, surprisingly, it's the same. So now the first question that students throw at me, then sir, why are we doing this? I'll tell you multiple reasons. Reason number 1, I have done assignment problems in my second year of statistics for an entire semester. And when we did assignment problems, we used to have, we did a lot, because we had an entire chapter in a semester. So I have done this for 6 months. And when we do this for 6 months, we do a lot of different kinds of questions. And there are different ways of doing this. What I have realized is that this method of drawing the lines gives you an answer quicker than any other method. Meaning, when I draw lines in this manner, sometimes this is not the same. Like these drawn lines and these drawn lines may or may not be the same. Does that mean it's wrong? No, it's not wrong. The redesigned matrix will be different. And then I don't guarantee you that you get an answer in the second attempt. Here, you got an answer in the second attempt. You drew the lines, you redesigned the matrix and you got an answer. If the lines are slightly different, I don't guarantee you that you will get an answer in the second attempt. You might have to draw lines again. So although this looks easy, there is a chance that you might not get an answer after redesigning. You will have to again redesign. With this, you get the answer in the least number of lines drawn. So this you might have to do once, or maybe in any question twice. This, then in that question, if you are doing randomly by inspection or you are doing by this method, I don't guarantee you that in 2 drawing of lines you will get an answer. You might have to draw 3 times also. So a lot of students find this method easy. It's up to you. There is no hard and fast. Let me show it to you once again so that it registers with you. 1, 2, 3, 4, 5. And then you can adapt this in every question. I have no problems with what method you choose. My end game is understand what you're doing and get me an answer, because anyway the institute expects that. The institute doesn't expect you to know each and every aspect of it. So 3, 2, 5, 2, 0, 0, 3, 2, 0, 3, 2, 0, 2, 0, 1, 0, 4, 0, 1, 4, and lastly 4, 6, 1, 3, 0. Let me do that for you again. This is a 0, sorry. 2 zeros cannot do anything. Fine. 2 zeros cannot do anything. Fine. 1 0, mark it as an assignment. You are going row wise. 1 0, mark it as an assignment. Cancel every 0 in that column. Agreed. Don't do that anymore. Cancel the entire column. You are going row wise. Cancel the column. You are in row number 2. Go to row number 3. Exactly 1 0. Mark it as an assignment. Cancel every 0 in that column, or now cancel the entire column. Done. 1 0, mark it as an assignment. Cancel every 0 in that column, or cancel the entire column. Last row there are 2 zeros. I can't do anything about that, so I start doing this column wise. 1 0, mark it as an assignment. Cancel every 0 in that row, or rather cancel the entire row. All zeros are marked or assigned, and I have drawn minimum number of lines. I will redesign the matrix. So what will you do henceforth? Step 1 row reduction, step 2 column reduction, step 3 assignment. If you get an assignment, and how will you do the assignment? Assignment we will do normally, which is row inspection. If there is a single 0, mark it, cancel everything else. And if you get an assignment, if you get 5 assignments, fantastic. Stick to this. Here, don't cancel the columns. If you don't get the 5 assignments, redraw the matrix, and now when you are assigning, start cancelling the columns. You cancel the columns, you get the drawn lines, select the least, subtract it from the uncovered, add it to the junction, leave the single covered alone, row reduction, column reduction, and assignment. That's it. That is how you solve an assignment problem. With this, the chapter assignment problem is done. Thank you very much.